Okay, so for question 1, we're given the equation y equals 2x squared minus 12x plus 16. We want to find the gradient at the point P is 5, 6. So if we see the keyword gradient, we're given an equation. In this case, it's a quadratic. Your first thing you should be thinking is we need to differentiate that. So we need to find dy by dx. We apply our general rules. We bring the power to the front as a multiplier. So 2 times 2 is 4. Drop the power by 1, so it's x to the power of 1, or just x. Minus 12x, when we differentiate that, we have minus 12. And the plus 16, when we differentiate that, goes to 0. So that's our differential. So that's going to be the equation for our gradient. Now we're given a specific point, 5, 6. So we can use the x value of this. So x is equal to 5. Substitute it in. 4 times 5 minus 12, which is equal to 8. So therefore our gradient at P is equal to 8. So a nice one to start with. Question 2. We're given the equation of 2 straight lines and we're told that they're perpendicular. We want to find m from this equation of the second line. So in order to do this, if we know that the lines are perpendicular, we know something about their gradients. What this implies is that the gradient of line 1 times the gradient of line 2 is equal to minus 1 by definition of perpendicular. So if we can work out the gradient of the top line, then we can use that to find the gradient of the second line. So if we take the top line then, so if we take 2x plus 4y minus 3 is equal to 0, we need to rearrange this to make y the subject. So 4y is going to be equal to minus 2x plus 3. So y is equal to minus a half x plus 3 over 4. And this is in the form y equals mx plus c, which is very good because the multiplier next to the x is our gradient there. So from this, we can say that m1 is equal to minus a half. So using the formula, we can say that we've got minus a half times m2 is equal to minus 1. So m2 must be equal to 2, or by the definition that they give, so just m is equal to 2 there. So that's our value for m. We're going to use that value to help us in part B, because part B says line L1 and L2 meet at P, find the x coordinate of P. Now notice it says the x coordinate. You could go on to find the y coordinate, but you don't need to. And if you do, you're actually wasting time. So if they meet, what that means is the x and y coordinates at that particular point must be the same. So for example, if we have 2 lines, the point that they meet would be P there, for example. And if they're perpendicular, that's approximately 90 degrees, but perpendicular means that they're at 90. So we want to find where they meet at P. So if we take our 2 equations then, we've got 2x plus 4y minus 3 is equal to 0. Let's just rewrite our line L2 with the new gradient, so y is equal to 2x plus 7. So y is equal to 2x plus 7. And all we're going to do is substitute the equation of this second line into the equation of the first line and then rearrange to find x. So combining those together, we can say that we've got 2x plus 4 times 2x plus 7 minus 3 is equal to 0. If we expand this, we've got 2x plus 8x plus 28 minus 3 is equal to 0. 10x plus 25 is equal to 0. So x is equal to minus 25 over 10, or when it simplifies, minus 5 over 2. So just to tidy that up, x point p is equal to minus 5 over 2. And that's how we deal with the first two questions.